Hello everyone. Today we are going to discuss recursion. Talking about the use case of recursion, recursion is not only important for solving a objective question in a placement, or for that matter, an interview gives you a question or you have to write some recursive code. Obviously, that is one of the use cases, but it is very important to understand recursion because as we go further and we try to understand the code of trees, graph, we have divide and conquer, merge, sort. So these things, everything at every point of going through DS algo, we find recursion very useful, and it is necessary and must to understand the concept of recursion. You should be very fluent with it before you proceed further. In this section, I will make you understand what recursion is. We'll solve some problems, but more the problems you solve, better you will understand recursion. And I think once you have understood recursion, it will make you, it will be much easier to understand further higher concepts. So let's try to understand what recursion is. So let's say we have 5 functions: f1, f2, f3, f4. So it may happen that there may be a code in which the first task is F1. So after F1 is done, so it may happen that F1 calls F2, then F2 calls F3, then F4 calls F4, F3 calls F4. Say when you go through an admission, so very first you, do your registration. After your registration is paid, so the person that sits on the registration counter, he just sends you to pay the fees. So you pay the fees. So after your fees is paid, he sends you to look for the class. So after one task is done, another function is getting called. So this is a kind of chaining that is occurring between the function. One function is calling another function. So this is a kind of chaining that is happening. So when one function calls another function, which in turn calls another function, so a process of chaining occurs. So what happens in recursion is a special case of chaining in which a function calls itself. So we had 4 functions here, but in case of recursion, we'll have only one function f1, and f1 will keep on calling itself. So that will be based on the scenario. We will see that what could be the scenario in which recursion happens. So what happens is, let's say you have a big problem. So what happens is you have a big problem and there is a code to solve this problem. Now what happens is, in order to solve this big problem, you have to divide this big problem into sub-problems. And the code to solve this sub-problem is also same. So the code that is supposed to be executed in order to solve a problem is same. It's just that the parameters will differ. So let's say we have a 4x4 matrix. And we have alphabets, say A, B, C, D, whatever, A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. And you are asked to find a particular alphabet. Say, let's say you have to find L. So what will you do? You'll start from here. Then you'll start from searching here. So first you'll go here, then you'll go here. And after you see that, okay, I was not able to find this alphabet in this particular row, you will go to another row. And then again, you are doing the same thing. You're starting from here and you are just going through this particular row to find that if a particular alphabet is there. So if you write this in terms of code, you see that you're doing the same thing again and again. So there is no point of writing different functions for this thing. Let's say it will be more clear if we try to understand this with factorial. So let's see what happens when we calculate a factorial. What is a mathematical function for it? So what happens is, suppose we have to calculate n factorial. What we do is n factorial is n into n minus 1 into n minus 2 into n minus 3 and till 3, 2, 1. So this is how we calculate a factorial. So if you can see that there is some repetition happening, like this particular portion, we can write this as n minus 1 factorial. Can't we? Yes, we can write. So again, this thing is calculating n minus 1 factorial. So we can write n factorial as n into n minus 1 factorial. Again, this n minus 1 factorial can be further divided in n into n minus 1 into n minus 2 factorial, because this particular part is n minus 2 factorial. So as you can see that we are doing the same task of calculating a factorial, it's just that the number inside or the parameter inside is getting changed. So as you can see, in order to get n factorial, first we have to solve n minus 2 factorial and to some, okay, so if we extend this further, this is 6 factorial, right? So in order to get 7 factorial, we have to get 6 factorial. So if we consider this in number, say let's suppose n is 5 factorial. So in order to get 5 factorial, we have to get 4 factorial. So in order to get 4 factorial first, we have to get 3 factorial. And in order to get 3 factorial first, we have to get 2 factorial. So you see there's a kind of division of some problems that's happening. So similar is the case of recursion. So what will happen, the code to calculate 2 factorial will be same as the code to calculate 3 factorial, and similar will be the case between 3 factorial and 4 factorial. So the code is getting repeated. The only thing is that the parameter is getting changed, or the number that we are passing to the code is getting changed. So let's try to convert it in a recursion. So let's say we want to calculate a factorial. So the function that will be calculating the factorial, say it is fact n. This is the function that will be calculating the factorial, and this will be the parameter. So this is calculating factorial n factorial. Now suppose this can be further written as n into fact of n minus 1. So as we can see that we are dividing sub problems. So let's try to write the code for fact. So let's say this is the number for which factorial has to be calculated. So we can see that, so as we have seen that the factorial of n is n into fact of n minus 1. So I'm just putting it, let's see what will be above this and below this. So this is n into fact of n minus 1. So what will happen here is, so let's say n is 5. So this will go like 5 into fact of 4. That will go to 4 into fact of 3. So as you can see, there is a problem here. So what is the problem? The problem is we haven't specified that where this code should stop executing, where this recursion will stop executing. So what is happening is fact 2 is calling fact 1, fact 1 is calling fact 0, fact minus 1 is calling fact minus 2. So the code will keep on executing infinite times, which is not acceptable. So there has to be a base condition. This base condition is supposed to terminate the program. So let's say we know that fact of 1 is 1. We know that 1 factorial is 1. And we also know that 0 factorial is also 1. So we write a base condition here. So we want our code to go only till when n is equal to 1. So we write a code here that if n equal to 1, return 1. So this returns the result of 1 factorial. So what is happening is we are writing a code and we know that it is getting divided into sub problems, but when n becomes 1, we know that it cannot be further subdivided, and we know that the value of 1 factorial is 1. So this is the base condition, which is responsible for terminating the particular recursion. So this is the code for factorial that we wrote in a previous program. So as we can see that this function is this particular fact is calling the fact again and again. So this is recursion. So let's try to understand that how recursion gets executed. So let's see, we take, whenever you have to try run any code, you can just take a value of n, like if we have n there, so you can just put n equal to 5 and you can see that how the code is executing and it is giving you a right result or not. So let's say here we try to calculate fact of 5. Okay, one more thing, that this is int. This means that this function will be returning an integer, and as it is here, that it is expected that an integer will be returned from here. So the very first thing that happens is, after n equal to 5, since n is not equal to 1, so it won't execute this part, it will go to this part, it will return n into fact. Okay, so what we are doing is we are storing the value of L, whatever this is, we are storing this value in L. So let's, for the sake of example, we'll store this value in L. So we have this n into fact of n minus 1. So it will come out to be n into fact of 4. Okay. Now what happens is, again this fact is getting called with a n value 4. Again n is equal to 1. No, this is not correct. So what will happen? It will again come here and the n will be 4 in this case, and what will happen? It will call fact of n minus 1, which is fact of 3. So again 3 gets executed when we get 3 into fact of 2. Again we get 2 into fact of 1. Okay. Now what happens is, since we have n equal to 1, the function will return value from here only. So it will return 1. So the 1, okay, let's say it will return 1, or we say that fact of 1 is equal to 1. So where this 1 will be returned? Who will return this particular result? So the function which has called this particular function, okay, it is a bit confusing, try to understand. The value, whatever we say that this function is returning a value, or where is the value returned? Value is returned to the calling function. So let's say if we have a main here, and main is calling fact of 5. So the ultimate result that will come out of that this function will be returned to main. But as of now, who called fact of 1? Fact of 1 was called from here. So from where will this 1 result be returned? It will be returned here. So what will happen? The value of fact 1 will become 1. Okay, let's see, let's put, this is fact 2, this is fact 3, this is fact 4, this is the function, this is the snapshot of function. Like fact 4 is further calling 4 into fact of 3, and this is fact of 5. So we are writing that this is the calling function and this is the further process that is happening. So what will happen? And this is fact of 1. Fact of 1 will return 1 to fact of 2. So this 1 will be returned to fact of 1, and the value here becomes 2 into 1, 2. And now this 2 will be returned to fact of 2, which was being called by fact of 3. So now what is the return value here? 3 into 2, which is 6. Now what is this? This 6 will be called to the calling function. So which particular function called this particular statement? Fact of 4. Now, fact of 3. Now fact of 3 will be replaced by 6. So it will be 6 here. And what will be returned to fact of 5? It will be 4 into 6, 24. Now again, factor 4 is replaced by 24. And what is returned to factor 5? 24 into 5, 120. So 120 is returned to factor 5. And since factor 5 was being called from main function, here 120 will be returned and hence the value will be returned. You try to solve this by yourself. This might get confusing to you. Let's see. So this is how things get executed in recursion. So what happens is, like, as we can see that we are just through pen and paper we are writing that, okay, this fact 1 is getting called, fact 2 is getting called, this result is getting back to fact 1. But this is a code that is getting executed in a memory, right? So there has to be a way for memory to store these particular function calls. Like, how will it know that, that I have to return 2 to fact 2? So there has to be a way to store these functions. So in memory, these functions are stored in a stack. So what is a stack? We have a complete session on stack. For as of now, just try to understand that stack is last in, first out, which means it is kind of a stack of a plate. Like, you put plates, and the last plate that was kept on the stack is the first one to be taken out. So it's just like let's say this is a close ended and this is open ended. So you put plate from here only, and you take out the plate from here only. So that is stack. It's just a pile of elements in which the last element that is pushed is the first one to be taken out, and the all elements that are being pushed just go on top of each other. As I said, that the stack of plates. Similarly, we have stacks in our system, that these recursive calls are stored in a stack. So let's say what happens. Let's go back to that fact example. Let's come back to this example. So what happens is, the very first function that was called was fact of 5. So fact of 5 will be let's say this is a stack. So fact of 5 will be the first, will be the first one to get into the stack. Or for that matter, let's say we have main here. Okay. So after main, we have fact. Since fact is the first function to be called, it lies at the bottommost part of the stack. So after fact 5, we have fact 4. Similarly, other functions lie on top of each other. So as we can see that functions are getting pushed from top, and as I say, it goes as last in, first out. So what will be the very first function that will be taken out from this stack? So what happens is that the first function will be fact of 1. This fact of 1 will be taken out, and whatever result fact 1 gives, it will be deleted from the stack, and whatever result fact 1 gives will be returned to fact 2. So this is how it goes. So after fact 1 has returned 1 to fact of 2, it does the calculation, and after that it returns 2 to fact of 3, and fact 2 is deleted from the stack. After fact 3 does the execution, it returns, I did a mistake here, so it returns 2 here and it returns 6 here. Yeah. So after it returns 6 to fact of 4. So fact 4 does its own calculation of n into 6, which is 4 into 6, that is 24, and this 24 is returned to fact of 5, and then 120 is calculated and that is returned to main, and this whole thing keeps deleting from the stack. So this is how recursion is presented in the memory. Okay, one small concept that is related to recursion is tail recursion. It's just kind of a definition. We say tail recursion is a case in which recursive call is the last statement to be executed. as we can see in the previous code, that this was the last statement to be executed. So this is tail recursion. So what might have happened that we would have added one more statement oh, since this is written, but we could have done that L equal to n into fact of n minus 1, and then we could have done print L, and then we could have returned L. So we can see that after this function call also there are two statements. So this is not tail recursion. This is the case of tail recursion when recursive method call is the last statement to get executed. Tail recursion has its use in some case of compilation optimization, compiler optimization. So this is a very small concept. Okay, let's try to understand this concept of recursion better by solving this particular code. So you have to give me the output. So what happens is we have let's say we have n equal to 4 here. So what we are doing is, if n is less than 0, we are returning, and obviously since this is what we are since this is void, we are not returning any value. So the first statement is this: you have to print the value of n. Next, this is a recursive call. We are again calling this function with parameter n minus 1. Then again, after this recursive call, we have to print n. So these are the two printf statements, and you have to tell me what will be the output of this following code. Try to understand by yourself. Try to print the output or get the output. If possible, you can run it in your system and see what will be the output. And after you are done with, then we will discuss what will be the solution of this particular thing and how that particular solution has arrived. I hope you have solved the problem. So in case you were unable to, let's discuss, and in case you have solved the problem, just match your answers. So let's try to solve this problem and reach the output. Okay, so what happens is, let's try to follow the stack approach. Okay, so what happens is, first int of 4, first print of 4 is called. So if n is equal less than 0, no, so this particular statement will get executed. Let's say we are writing output here, and 4 will get printed. Here 4 will get printed. Again print n minus 1, which is print of 3. Again the same thing will happen. Printf will come here, the execution will come here, and 3 will be printed. Now again this function will get called. There will be a recursive call, and 2 will be a print of 2 will be called. Again, and 2 less than 0, no, will come here, will print 2. Again we'll have n minus 1, which is 1. So print of 1 we'll have print of 1. It will go through this process, and then 1 will be printed here. Then again we have print of n minus 1, which is 1 minus 1, 0. So again the function will come here, the execution will come here. This condition won't get executed, and 0 will print it. Now we have print of minus 1 will get called. Okay, since now this statement will get executed, n is less than 0, yes, so it will return. So what will happen is, okay, I've drawn a kind of opposite stack. So let's say this is the open end of stack. So what happens is, now print of minus 1, it has nothing to return, so it will just be removed from the stack, and the control will go here. So again the control will come to print of 0. Okay, see, print of 0 got executed. So what happens is, after you return a value, or after the previous function has returned the value, and for that matter in case of void it has just returned, the control again comes back to the place from where it was called. So print of 0 was called from here. And now what happens is, if there is any statement after that particular call, recursive call, or function, after that recursive call statement, those statement will get executed. So this is, in this case, let's say this is print of 0, what will happen now, that whatever statement is there after this, that will get executed. And what do we have the value of n here? It is 0. So I'm writing it on another line. Now what will happen? 0 will get printed. Okay. So after 0 gets printed, we don't have anything else to execute. Again, print of 0 will be removed from the stack, and the control will go to print of 1. So again, it will be print of 1. So what will happen again? It will see if there is anything to execute after this. So we have to print n, and n in this case is 1. Now, so what will happen? 1 will get printed. Similarly, after code of this function gets executed, this will be removed and the control will go to print of 2, which is here. Now again, we have to print n here, which is 2. Similarly, 3 and 4 gets printed. So this is how, so this was to make you understand that what happens after the in recursive call, after the function returns its value. So what happens to the statement that are before the particular recursive call and after the recursive call. So I'll give you a problem statement based on this concept.